Welcome students in the era of objective type question part 2. This topic is completely based on the chapter atoms and the most important content related with the CBSE NEET as well as the IIT JEE examination. So let's begin with the class 12 physics objective type question part 2 session 1. The first question is, in the Rutherford experiment, the number of alpha particles scattered through an angle 60 degree is 112 per minute. Then the number of alpha particles scattered through an angle of 90 degree per minute by the same nucleus is 28 per minute, 112 per minute, 12.5 per minute, 7 per minute. Let's see the solution. So number of alpha particles scattered at an angle theta is given by n theta is equals to n tz square e to the power 4 by 8 pi epsilon naught square r square e square sine to the power 4 theta by 2. Where we are taking only the component this, that n is directly proportional to 1 by sine to the power 4 theta by 2. Where n1 is equals to 112, theta 1 is equals to 60 degree and theta 2 is equals to 90 degree. We have to calculate n2. Students, this complete formula is not important actually, but the terms are important. This is the complete formula, whereas we are taking for the examination purpose only this. It's important, not for only the board examination, yet important for IIT JEE, NEET, as well as the board examination, which is important for 2023 board. So n1 by n2 is equals to sine to the power 4 theta by theta 2 by 2 and sine to the power 4 theta 1 by 2. After putting all these values, we get the value of n2, which is 28 per minute. I hope you understand the concept, students. So this is the option 1 is the right answer. Next question is, alpha particles are projected towards the nuclei of the different metals with the same kinetic energy. The distance of the closest approach is minimum for copper, Z is equals to 29, Ag, Z is equals to 47, Au, Z is equals to 79, and platinum, that is Z is equals to 46. Polonium, I think. So solution is distance of the closest approach between the bombarding particle and the target scatter is d is equals to 1 by 4 pi epsilon naught 4 ze square by m k v k square, which is equals to 2 k ze square by ek, where d is directly proportional to z. Students, this formula which I am explaining to you, this write down in your short notes so that during the exam we don't have to memorize all the formula or not collection on this formula. According to that, the correct option is Cu Z is equals 29. 3. Angular momentum. The angular momentum of the electron is Z. Its magnetic moment will be mj by 2e, ej by 2m, 2m by ej, or emj by 2. So, let's move with the solution part, students. Magnetic moment by angular momentum is equals to E by 2m. So m by j is equals to E by 2m. So from here we get the value of a capital M, which is Ej by 2m. Now further we can say the correct option is option 2. If further we are just taking our next question. So the fourth question is, the acceleration of electron in the first orbit of an hydrogen atom is 4 pi square m by h cube, h square by 4 pi square mr, 3 h square by 4 pi square m square r cube. The fourth option is m square h square 4 pi square m r cube. So the solution is the acceleration of the electron in the first orbit of the hydrogen atom is A is equals to V square by R. But we know that angular momentum in the circular motion is always conserved. So mvr is equals to h by 2 pi. Means V is equals to h by 2 pi mr. So from here we can calculate the value of A, which is h by 2 pi mr whole square by r. That comes h square by 4 pi square m square r cube. Hence we can say the correct option is 3. Next question is when an hydrogen atom emits a photon of energy 12.1 electron volt, its orbital angular momentum changes by 1.05 10 to the power minus 34 joule second, 2.1 10 to the power minus 34 joule second, 3.16 10 to the power minus 34 joule second, and 4.22 10 to the power minus 34 joule second. Let's move with the solution part. To change in angular momentum, delta L is equals to h by 2 pi n1 minus n2, energy of photon, which is equals to 12.1 electron volt. This is possible when n is equals to 3 to n is equals to 1. Delta L is equals to 6.62 10 to the power minus 19 divided by 2 into 3.14. This is the equation number 2. So after solving a bit, we get the values 12.5 10 to the power minus 34 by 6.28. So this is a multiplied, not equation. This is a multiplied by 2. This factor is a multiplied by 2 factor. Okay. So after multiplied this factor into 2, we get this value. So delta L comes 2.11 10 to the power minus 34 joule second, which is the correct answer 2. Next, the kinetic energy of an electron in an orbit of radius r in hydrogen atom is E is equals to electronic charge. It comes first equation, first like option k e square by r square. Second option is here k e square by 2r. Third option is here k e square by r. And the fourth option is k e square by 2r square. So moving with the solution part, kinetic energy 2 pi square k square e to the power 4 by h square comes with the mz square by n square. R comes n square h square by 4 pi square kzme square. So kinetic energy, which is equals to kze square by 2 times n square h square by 4 pi square kzme square, which is equals to kze square by 2 pi n. For hydrogen, Z is equals to 1. Kinetic energy is equals to k square by 2 pi 2 nr, which is the second option. Next question is the energy necessary to remove the electron from n is equals to 10 state in hydrogen atom will be first 1.36 electron volt, 0.0136 electron volt, third is 13.6 electron volt, fourth is 0.136 electron volt. The solution which we get here, energy required, that is E infinite to E10, which is equals to 13.6 n square is equals to 13.6 10 square. After solving with bit, we get the answer 0.136 electron volt. That means we have the correct option is the fourth option. Next question is the value of a wavelength radiation emitted due to the transition of electrons from n is equals to 4 to n is equals to 2 state in a hydrogen atom will be 5r by 36, 3r by 16, 36 by 5r and 16 by 3r. So the solution is the wave number k is equals to 1 by lambda, which is equals to r times 1 by n1 square minus 1 by n2 square. n1 is equals to 2, n2 is equals to 4. So 1 by lambda is equals to r times 1 by 4 minus 1 by 16. That r is equals to r times for 12 by 16 into 4. After solving a bit, we get the answer lambda is equals to 3 by 16 times of r. That is the second option is the right answer. Ninth question is 2 electrons in an atom are moving in an orbit of radii r and 9r respectively. The ratio of their frequencies will be 1 ratio 8, 8 ratio 1, 1 ratio 27, 27 ratio 1. So the solution part is t square is proportional to r cube. T1 square by T2 square is equals to R1 cube by R2 cube. T2 square by T1 square is equals to R2 cube by R1 cube. which is equals to 9r cube, 9r whole cube by r cube. So r1 is equals to r2 is equals to 9r. We just put this value and get the value of t2 by t1 is equals to 27 by 1. Students, this is the important formula. So please prepare this formula for board examination as well as for the IIT with the NEET. So correct option is the fourth option. Next, the ratio of the speed of electron in the ground state of a hydrogen atom is that of light is 1 by 37, 1 by 137, 1 by 207, 2 by 237, and the last 1 by 237. So let's move to the solution part. Students, we know that speed of electron in the ground state of a hydrogen is Vn is equals to C by 137 Z into N, Z by N. So where C is the speed of a light, so Vn by C is equals to 1 by 137 times Z by N. V by C is equals to, for hydrogen, Z is equals to 1 and N is equals to 1. So the correct answer is 1 by 137. 11th question, the ratio of difference of energy between the energy level with n is equals to 3 to n is equals to 4 and the spacing between the energy level with n is equals to 8 and n is equals to 9 for an hydrogen-like atom or ion 0.71, 0.41, 2.43, 14.82. Let's move with the solution part. So E1 by E2 is equals to N2 square minus N1 square by N2 square minus N1 square. Again, just put all these value together and get the value of a 7 by 17. After solving, this value comes 0.41. That means the correct option is 2. 12th question is, the minimum wavelength of Paschen series of a hydrogen atom will be 18,700 angstrom, 970 angstrom, 1022 angstrom and 8181 angstrom. Solution part is line corresponding to N2 is equals to 4, 5, 6 to infinite to N1 is equals to 3 constitute Paschen series for a minimum wavelength N2 is equals to infinite and N1 is equals to 3. So 1 by lambda min is equals to R times 1 by N1 square minus N2 square, which is equals to R times 1 by N3 square minus 1 by infinite square. So 1 by lambda min is equals to R by 9. So from here we can calculate the value of R min, which is equals to 9 by R equals to 8181 angstrom, which is option number 4. 30th question is, we have the number of different wavelength may be observed in the spectrum from hydrogen sample if the atom are excited to the third excited state is 3, 4, 5, 6. So the solution part is the number of a different wavelength are observed in the spectrum. That n is equals to n times n minus 1 by 2 and 4 is times 4 minus 1 by 2, which is a 12 by 2, option 6. 14th question is, the energy of a hydrogen in the ground state of hydrogen atom is 13.6 electron volt. The energy required for transition from n is equals to 2 to n is equals to 3 will be 2 electron volt, 4 electron volt, 1.88 volt, 2.89 volt. Solution will be, the energy required for the transition from n is equals to 2 to n is equals to 3 will be delta En is equals to E2 minus E3, which is equals to minus 13.6, 1 by 2 square minus 1 by 3 square. After solving a bit, we can get the value of minus 13.6, 1 by 4 minus 1 by 9. So, after a solution, we get the value of 1.88 electron volt, which is the option number 3. Last question, which of the following statement is correct or are correct? The ratio of minimum to maximum wavelength of radiation that an excited electron in the hydrogen atom can emit while going the ground state is 3 by 4. A hydrogen atom in an excited state of the principal quantum number n emits a photon of wavelength lambda. While returning to the ground state, the value of n is under root lambda r by lambda r minus 1. A and B are correct. Second, A alone is correct. Third, A and B both are wrong and B alone is correct. The correct answer for this question is, let's move with the solution part so that we can see the clear picture of this question. E is equals to minus 13.6, 1 by n1 square minus 1 by n2 square electron volt, where E is the minimum when n1 is equals to 1 and n2 is equals to 2. E minimum is equals to minus 13.6, 1 by 1 minus 1 by 4, which is equals to minus 13.6, 3 by 4 electron volt. E is the maximum when n1 is equals to 1 and n2 is equals to infinite. E maximum when this will be equals to minus 13.6, 1 by minus 1 by infinite, which is equals to minus 13.6 electron volt. So E minimum by E maximum is equals to 3 by 4, which is equals to SC by lambda max by SC by lambda min, which is equals to 3 by 4. So lambda min by lambda max is equals to 3 by 4. This is the correct opinion for the first one. And the one that is a 1 by lambda is equals to 4 r times 1 by n1 square minus 1 2 square. So 1 by lambda is equals to r times 1 by 1 square minus 1 by n2 square, which is equals to r minus r by n1 n square. So n comes with the value under root lambda r by lambda r minus 1. Students, as we can see, again I am repeating that 1 by lambda is equals to r times 1 by n1 square minus 1 by n2 square. 1 by lambda is equals to r times 1 by the value of n1 is equals to 1. So I'm just putting n1 is equals to 1 square minus n2 is equals to n. So 1 by n square, r minus r by n square. After solution, we get the value of n, which is the option number 1. I hope you understand all these questions with the concept, with the solution part. If there is any doubt yet, so you can ask your doubt in the chat session, in the comment box. Till that, take care everyone, and thank you for watching this Nagin group of digital learning and institution. So, thank you.